Welcome to Statistics Insights. Today I'm going to solve some problems of IIT-JAM 2022. It includes numerical answer type questions, multiple select questions, and the multiple choice questions. So let's begin. So in this question, it is told that x1, x2, and x3 following normal 0, 1, and these three variables are IID variables. So let's consider the variable u, twice x1 square x2 plus x3 whole square. Now since x1, x2, x3 following standard normal distribution, so what we can do, x2 plus x3 would follow normal 0 and 2, that we can further reduce to x2 plus x3 divided by root 2, that would follow normal 0 and 1. So if we square the whole term, x2 plus x3 whole square, that would be 2. This would follow the square of the standard normal distribution is a chi-square distribution with 1 degrees of freedom, and x1 is given to follow normal 0, 1, then x1 square would follow chi-square with 1. So u is equals to, since this one is also chi-square, this is also chi-square, the ratio of two chi-square will follow f distribution. So let's construct x1 square divided by its respective degrees of freedom, x2 plus x3 whole square divided by 2 divided by its degrees of freedom 1. This would follow f1 oblique 1. This means u is following f1 1. Now come to v. We are given that 2 x2 minus x3 whole square, twice x1 square plus x2 plus x3 square. Now x2 minus x3 would follow normal distribution with mean 0 and variance will be 2, right? Then we can further reduce it to chi-square by scaling the x1 minus x3 variable. We have scaled it by root 2. This would follow normal 0, 1. And it is obvious that if we square it, it would follow chi-square with 1 degrees of freedom. Fine. Now again we are given x2 plus x3. There we have done x2 plus x3 would follow this one, and if we standardize it, or if we scale it, it would follow x2 plus x3 whole square by, it would be 2. This would follow what? Chi-square with 1 degrees of freedom. Okay, now what we do, and yes, and we are given x1 square also. This would follow chi-square follow chi-square with 1 degrees of freedom. Now by addition theorem of chi-square, if we add x1 square and this term, let's see what it's happened. X1 square plus x2 plus x3 whole square by 2, this would follow chi-square with 2 degrees of freedom, right? Now for f distribution, let's see if it is f or not. Now for this term, x2 minus x3 whole square, sorry, here it would be 2, x square by 2, and its degrees of freedom is 1, so there is no necessity of writing the 1 in the denominator. Then x1 square plus x2 plus x3 whole square by 2, and its whole degrees of freedom is 2, right? Then these 2 and these 2 get cancelled out, this one and this one gets cancelled out, so what we have, x2 minus x3 whole square, and if we take LCM of this one and this one, LCM as 2, the 2 will appear in the numerator, and this would be x1 square plus x2 plus x3 whole square. Now this follows, here it is 1 and here it is 2, this follow f1 comma 2 degrees of freedom. Okay, now look which option is correct. U has f11, U has f11, yes, V has f12, V has f12, so option A is correct. Further checking, U is 11 and V is f21, this is incorrect. And let's see for C, U and V are independent. Yes, U and V will be independent because we are given that x1, x2, x3 are independent, okay, are independent, we are given this one. So we know for any measurable functions, the functions of x1, x2, x3 will also be independent, so U and V are also the functions of x1, x2, x3. This one is also function of x1, x2, x3, so this one is correct. Now comes to option number D. Let me rub some of the part. So it's fine. Let's check for number D. For number D, we are given that half of v1 plus u. Okay, this can be written as half v is what, 2x2 minus x3 whole square divided by twice x1 square x3 whole square. V, then 1 plus u. U is what, twice x1 square x2 plus x3 whole square. Okay, this is fine. Now what we can write, these 2 and these 2 get cancelled out. x2 minus x3 whole square twice x1 square plus x2 plus x3 whole square, and take the LCM here. x2 plus x3 whole square plus 2x1 square. This term and this term gets cancelled out. Now what remains, x2 minus x3 whole square and x2 plus x3 whole square. Now this should follow what? This should follow f1 and 1. You can check it. So it is given that it has f23, and this is wrong. So we are done with this one. Let's move on to the next question. Now these questions, what it said, let xn be a sequence of independent and identically distributed random variables, each having uniform 0 1 distribution, and we are given that yn is equals to n multiplied by smallest order statistic. Okay, and we are given that if yn converges to y in distribution, then the median of y is equals to what? So let's do it. What we are given, yn to y in distributions. This means limit n tends to infinity f of yn of y would converge to f of y, right? Now for that, what we do, let's derive the distribution function of f of yn, and this is probability of yn less than is equals to y, and we are given that yn is equals to n into minimum of x1 xn less than is equals to y, right? Now what we can do, minimum of x1 xn less than equal to y by n. Now we know the CDF of the minimum order statistics is 1 minus f of, here it will not be f of x, it will be f of y by n, because here it is f of y by n to the power n. Okay, 1 minus here with respect to x size, 1 minus y by n to the power n, right? Then what we do now, limit n tends to infinity f of yn of y is equals to limit n tends to infinity 1 minus y by n to the power n. Now this goes as this, here will be y 1 minus limit n tends to infinity 1 minus y by n to the power n, 1 minus e to the power minus y, right? What? This is the CDF of, this is the CDF of, this is the CDF of exponential with parameter 1. This means f of y is equals to e to the power minus y. And we know the median of exponential distribution is, median of exponential distribution is log of 2. So the answer is log of 2. So let's move on to the next question. This is a bit tricky problem. Not tricky, simple. We are given the observed values of a random sample. Its size is 4, and the continuous distribution or continuous probability density function is given. We need to estimate theta with the help of method of moments. Now look, we are given f of x is equals to 1 by 8 exponential of x minus 2 plus 3 by 4 under root of twice pi exponential of minus 1 by 2 x minus theta whole square. Okay, so what you can observe here, it is a combination of two PDF. One PDF is 1 by 4 into 1 by 2 e to the power minus x minus 2 plus 3 by 4 1 by under root of twice pi. This is a PDF of exponential normal distribution with variance 1 and mean theta, and this one is double exponential, and this one is normal. Fine. Now we need to estimate theta with the help of method of moments. So let's do it. What it would be expectation of x? It will be 1 by 4 into what its mean? Its mean is 2 plus 3 by 4. What is the mean expectation? It is theta into theta. Now we calculate the expectation of x with the help of this one. We get approximately equal to expectation of x is equals to 0.875 and 1 by 2 plus 3 by 4 theta. Okay, now 0.875 minus 0.5 into 4 whole divided by 3 is equals to theta cap method of moment estimator. Theta cap ME is equal to 0.5. Calculate it, you will get 0.5. So our answer is 0.5. So let's move on to the next question. Now this is a tricky problem. Let's do it. We are given the moment generating function of x and y. it is given that m of t1 and t2 equals to half of e to the power minus t1 plus half of e to the power t1 whole square, half plus half of e to the power t2. Okay, it consists of two moment generating function. It is a product of two moment generating function. Let it be m x t1 and it is m of y t2. Fine. As you can see, this part of the MGF, it is in the form of q plus p to the power 3. So y would follow binomial. What would be n? It would be 2. What would be p? It would be half. Fine. Now mx of t1, that we have to break it out. Minus t1 plus half e to the power t1 whole square. Let's take the half outside. What would we get? 1 by 4 e to the power minus twice t1, square it, e to the power twice t1 plus 2 e to the power minus t1 e to the power t1, 1 by 4 e to the power minus 2 t1 plus e to the power twice t1 plus 2. Fine. Now half, if we multiply 4 to the whole terms here, half plus 1 by 4 e to the power twice t1 plus 1 by 4 e to the power minus 2 t1. Now as you can see, x has values minus 2, 2 and 0, and the corresponding probabilities are minus 2, 1 by 4, 1 by 4, and here 1 by 2. So we have got the distributions of x and y. Now what we are asked? We are asked to find probability of x plus y is equals to 2. This means we need to find the probability of x plus y that would yield us plus minus and 2. Now what are the possibilities to get plus minus 2 if we add x and y? So for getting 2, for getting 2 we have the following possibilities of x and y. We can have x as 2, y as 0, and we can have x as 0, y as 2. So this is the possibility. No other possibilities can be derived. Now for getting minus 2, we have the following possibilities x and y. What are the possibilities? Only one possibility. X is equals to, sorry, no, we will not write x, we just write the pair -2 and 0, forgetting -2 if we add x and y. Now required probability of x equals to 2, y is equals to 0, either this one or this one, or this one. Fine. What do we get? Probability of x equals to 2 and probability of y is equals to 0 plus probability of x equals to 0, probability of y is equals to 2. And we know that x and y are independent from the moment generating function. The product has been written, the joint MGF is written as the product of the individual moment generating function. So we know, so we get the variables x and y as independent. X equals to -2 and probability of y is equals to 0. Now for x equal to 2, what we have? 1 by 4. 1 by 4, and y is equals to 0 is 2c0 half to the power 0 half to the power 2. Probability of x equal to 0 is half. Y is equals to 2, 2c2 half to the power 2 and half to the power 0 plus x equals to -2, 1 by 4. 1 by 4 into probability of y is equals to 0, so 0 half to the power 0 half to the power 2. What we get? 1 by 4 into 1 by 4 plus 1 by 2 into what we get here, 1 by 4 plus 1 by 4 cross 1 by 4. Fine. Then next, if we sum it, what we get? Here it is 1 by 16, here it is 1 by 16, so 2 by 16 plus 1 by 8. It's 16 in the denominator and 2 plus 8, 2, 4 by 16, 4 by 16, so 1 by 4 is equals to 0.25. So this is the required probability. All fine. Let's move on to the next question. This is the tricky problem. Tricky, and also it is tough problem. So let's do it. This is the PDF of double exponential, right? and we have to check uh, if these options are correct. The multiple options may be correct. So what we have in our hand is f of x is equals to 1 by 2 exponential of x minus theta. The support of x is the real line, and theta may belong to the real line. Right. Now the likelihood, since 4 samples are given, likelihood can be written as this. This is xi. Now look, there is no possibility to differentiate the likelihood and get the MLE of theta, or the sufficient statistic of for theta. For maximum likelihood, is maximized for smaller fine. So what we can write, xi minus theta. If we write xi minus theta by ordering the xi's, will the summation change? No, it will remain the same. Let's consider an interval for theta for any j. Let xj j plus 1. Let us assume that theta lies within this range. So what we can write, if we consider the general case of containing n random variables, what we can write, xi minus theta is equals to I goes from 1 to j, theta minus xi plus the next interval would continue from j plus 1 to n, and here theta is less than xi minus theta. Okay, what we get here, j theta minus I goes from 1 to j xi plus summation I goes from j plus 1 to n and xi. The remaining term should be n minus j theta. Fine. Now j theta, if we bring this one to the foremost part, minus n theta plus j theta. What do we write? Functions of xi. Functions of xi. Okay, no problem. There is no necessity of the statistic here, so we are concerned about theta. So what we get? Twice j theta minus n theta minus or plus functions of theta, functions of xi, sorry. Now if we take out the theta, twice j minus n theta plus the same term. Okay, now see, if j is less than n by 2, let us consider the term as a. The term a decreases, and if j is greater than n by 2, the term a increases, right? So what we observe, we observe that the likelihood remains constant within x n by 2 and x n by 2 plus 1, right? This means this imply that the maximum is attained within the interval x n by 2, sorry, it's a order statistic, within the interval x n by 2 x n by 2 plus 1. Therefore MLE is any number in between the above range. Done. So what we can infer that there is no unique MLE in this case, but in option A it is given that x2 plus x3 by 2 is the unique maximum likelihood estimator of theta. So this automatically gets cancelled out. Now let us suppose that let us consider theta cap MLE to be the x2 plus x3 x2 plus x3 divided by 2. Alright, let us consider this one. Now we are given this option. Let's verify it. It is given 1 by 4 x2 plus x3, x2 plus x3 plus 2. 1 by 4 x2 plus x3 and x2 plus x3 plus 2. Let's multiply the whole terms. What do we get? X2 square plus x2 x3 plus twice x2 plus x3 x2 plus x3 whole square plus twice x3. Fine. Now what we can do? Rearrange it. X2 square plus x3 square plus 2 x2 x3 plus 2. We take common 2 from these two terms. X2 plus x3. Done. These whole terms would imply x2 plus x3 whole square plus 2 x2 plus x3. Fine. Now let's multiply 1 by 4. 1 by x by 2 x3 whole square plus 1 by 2 x2 plus x3. See, if we consider theta cap MLE to be x2 plus x3 by 2, then by the invariance property, g of theta is the MLE of g of x. Okay, we can say this is the theta square plus theta, MLE of theta. This came after applying the invariance property of the maximum likelihood. Theta 1 plus theta. So this option is correct. Fine. Now let's check number B. For B, it is told that the order statistic is, the whole order statistic is sufficient for theta. Yes, it is possible because 1 by 2 exponential of x minus theta belongs to the location families having the form of the PDF as f of x minus theta. This means T of, in case of location family, the order statistic is sufficient for theta. Here in this case, n is 4, is sufficient for theta. No other reduction is possible. no other reduction is possible. Reduction in the sense the reduction of the original data x. If you want to see the proof for the location family, so the order statistics is sufficient for theta. You can refer to the book named Lehman. Lehman. It was published in the year 1983, and the page number was P page number page 43. You can refer to this book to see the complete proof that the location families has sufficient statistic, which is the whole order statistics. So let's end here. Thanks for watching.